This is lesson 3.1 from our Precalc 12 class. Unit 3 is called Trigonometry. And we're going to break the trigonometry unit into 3 chunks of learning, each with their own quiz. So here we go. Lesson 1 is called Radians. What we're going to talk about in this lesson is what is the unit circle, what do we do with it, and what are radians. So far in math class, up till grade 12, we talk about trigonometry with sine, cosine, and tangent. And our basic definition starts from a right triangle. We identify some angle theta, and we figure out opposite, adjacent, and hypotenuse lengths, and we make fractions out of those side lengths depending on which trig function we're using. The problem with right triangle trigonometry is that theta can only be numbers between 0 and 90, not including 0 and not including 90. It could be 0.1 all up to 89.99, etc. But we want to be able to do trigonometry with negative angle numbers as well as angle numbers 90 and above. Or in other words, we want to use our sine, cosine, and tangent functions with any angle value that you could possibly think of. And so in order to do that, we need to get rid of our current definition of trig functions, which means we need to say goodbye to triangles for a while. Please appreciate my humor. It's on the slide. Anyways, okay, so for that reason, we're going to abandon the right triangle for now, and we're going to introduce the unit circle. We can do so much more trigonometry on a circle than we can a triangle. I will point out briefly that the unit circle is nothing more than an infinite sum of right triangles, but it's not important right now. The next thing I want to talk about is radians. And so we measure angles in degrees. 0 degrees, 90 degrees is a right angle, 180 degrees is halfway around the circle, and 360 degrees is a full circular rotation. And so we also measure angles with a different measurement system, and that's called radians. Kind of like how y'all use Celsius in Canada, and where I'm from in the States, everybody uses Fahrenheit. Just different units of measure to measure the same thing. What I like about radians is that it's a little bit more intuitive once you get the hang of it. It's a little more basic too. So anyways, if we say that this is the unit circle, and the unit circle has a radius of 1. So if I go from the center, the origin, that would be the center of the circle, all the way out to the edge of the circle to the right, it's going to be a length of 1. So this point over here will be the point 1, 0. If I go straight up, we get the point 0, 1. If I go straight left, we have a negative, we're going on the negative x value, so going left 1 is negative 1, 0 would be this point. If we go down 1, we get 0, negative 1. I can take the idea of the radians as being the length of the circumference of the unit circle. So a full 360 degrees would be 2 times pi times the radius. Well, the radius is 1, so it's just 2 times pi times 1, which is just 2 pi. So we can conclude that a full 360 degrees in radians is just 2 pi. 2 pi is our radian angle measure, and it measures the same thing as 360 degrees, one full circular rotation. Well, we can conclude a lot of other things from that, either from the circle or from this equation. Half of a circle would be 2 pi divided by 2, which is just pi. But half of a circle is also a flat line, so it's 180 degrees. So 180 is pi. And that's probably the most useful conversion metric to memorize. Pi is 180 degrees. 180 degrees is pi. But we can keep cutting those in half and finding more equivalent radians. So if we take half of 180, we get 90 degrees. So that's going to be half of pi over 2. We could do half of that, which gives us 45 degrees is pi over 4. Or we could take a third of 90 degrees. A third of 90 is 30, and a third of pi over 2 is pi over 6. You're going to give it pi over 2 times pi over 3 is, just multiply top and bottom. So anyways, these 3 angle measures are also going to be very, very useful for us in this class. We're going to call these angle measures our benchmarks. We don't want to know, we could know all radians, but really we just want to usually just get a good estimate. And so these benchmarks gives us a nice estimate on the unit circle. So we'll live in those areas. Okay, so for your homework, we're going to drill in the idea of radians. So think of one radian, or one, like pi radians is a half a circle or a semicircle. 270 degrees is more than 1/2 circle, so in radians it's going to be more than pi. Well, I also know that 270 is 90 plus 90 plus 90, and we said that 90 degrees is pi over 2, so 270 is equal to pi over 2 plus pi over 2, well that's pi, plus another pi over 2, that is 3 pi over 2. Example A, 45 degrees is half of 90 degrees, and 90 degrees is pi over 2, so 45 is pi over 4. If you would like a procedural way of doing it that works every time, you could think of pi as being 180 degrees. So what we're going to do is we're taking our degrees, multiplying it by pi, and dividing it by 180, and that'll convert it to radians. So 45 times pi divided by 180 is going to end up being 1/4 pi. 45 goes into 180 4 times exactly, so it's pi over 4. We could do the same thing with example B. 270 times pi divided by 180. Well, that's 27 pi over 18, which reduces to 3 pi over 2. So 2 ways you could think about it. The concrete way, thinking of the semicircle. We have a procedural way of multiplying by pi, dividing by 180. Either way goes from degrees to radians. Okay, so here's some examples more. You could visualize a semicircle, or you could just multiply by pi and divide by 180. Here's our rule right there. The inverse function would be taking radians and multiplying it by 180. Oh, we won't get there. But yeah, you can multiply by 180, divide by pi of your radians, and you go back to degrees. But that's not what we're doing here. I'm ahead of myself. Don't do that. Okay. So take your angle for any of these angles, multiply them by pi, divide by 180, and then we just simplify the fractions accordingly, and we can find our degrees equivalents in radians. Take a moment, make sure each of these examples make sense to you, and then we'll move on. Right. I need to pause the video because I'm moving on. What we learned in this lesson is that the unit circle can help us do trig functions more than the right triangle can help us. So we're changing our definition of trig functions. And we also found that we can use radians to measure angles, and we learned how to convert degrees to radians.